Good morning, grade 9 students, and welcome back to the physics class. In this video, we're going to continue the first part, which is about chapter 5, DC voltage. Concerning the objectives of the previous video, of this video, at the end, you will be able to Before we start with the new objectives, let's get the answers of the questions that were posed in the previous video and which were about the electric circuit. Starting with the definition of an electric circuit, we can simply define it as the complete pathway for the flow of electric charges. And for these charges to flow, there must be some components, and because of that, an electric circuit is mainly made up of a generator, like this DC generator, which is a dry cell, a receptor, or a load, or an appliance that provides something called resistance. The load resists the flow of current. So, for example, if the current is flowing through the filament of this lamp, the filament is going to resist the flow of electric charges. Let's have a look at this picture. Here we have Mr. Volt, who is pushing Mr. Amp. And Mr. Amp is unable to travel so fast. And who is behind this? Yes, it's obvious. This is because of Mr. Ohm. In fact, Mr. Volt, or the push which is done by Mr. Volt, represents the voltage delivered by the dry cell. And Mr. Amp right here represents the electric charges that are flowing. And Mr. Ohm represents the resistance which is provided by the receptors or the loads. And now let's continue listing the components of an electric circuit, and if you check these two together, they can't make a complete pathway. So we still need a connecting wire. We need connecting wires that provide negligible resistance. Now let's move to the types of electric circuits. In the previous video, you have seen two. However, I'm going to talk about three types of electric circuits. Starting with the closed circuit, which provides a complete pathway for the charges, so they will traverse the loads, and thus the appliances or the loads are going to be functional. The second type is the open circuit, which is characterized by a broken, incomplete pathway, and because of that, the appliances are not going to function. And finally, the last type is the short circuit, which provides at a certain level an alternative pathway, which is usually an unintended pathway for the flow of charges, and we consider such a circuit as a dangerous circuit. Now, let's have a look on some circuits like this one, where the appliance turns on and then turns off. We have the second one and the third. Pause the video and try to match these types to the corresponding figure. And now let's see the closed circuit. this one is the closed circuit. We have a complete pathway and the lamp is glowing. So the conditions are met. The open circuit is this one because the switch right here is open, so we don't have a complete pathway, and because of that, the lamp is not glowing. And finally, we have the short circuit, which is characterized by an alternative pathway. So let's have a look right here and let's say that this is the current flowing out of this point, reaching this particular point. We have two pathways, one holding a lamp and one is just simply a connecting wire. And we have seen right here that the lamp shows some resistance while the connecting wire shows negligible resistance. So if we were just like electrons standing upright here and we have two choices, so I think that most of us are going to pass through this pathway instead of this. Because of that, the lamp didn't glow, and at the same time there is a high risk for this wire to melt or cause fire, and because of that we consider the short circuit as a very dangerous circuit. You have seen the short circuit in the previous video, just as in this part. So the electric charges didn't flow across the wire and instead they used to move across this pathway. So it is really dangerous to have such a wire at home. And in case we have a bare wire, it should be covered right here by an insulator. And once I say insulators, so it would be helpful if we recall the difference between conductors and insulators. Materials could be classified as conductors, which are matter that allows electrons to flow easily across them, just like the metal right here, including copper, for example. And concerning insulators, they are characterized by preventing the easy flow of electrons across their atoms. And as an example on insulators, we have plastic. Now it's time to make an application on all the previous objectives. So we have these two figures, two electric circuits. Check them well, pause the video, and then starting with the first question, you have to list the components of the electric circuit in figure 1. Start writing your answers. Yes, we have the dry cell, we have the lamp, connecting wires, and the steel paper clip. Moving to the second question, what does the inscription 2V? Here it is. What does it represent? Pause the video and think about it. Yes, it represents the voltage which is delivered by the dry cell. It's the potential difference across the terminals of the dry cell. Moving to the third question, knowing that the lamp of figure 1 glows normally, indicate its rated voltage and justify. Once I say that the lamp is glowing normally, this means that the needed conditions of this lamp are met. Once I say that it glows normally, this means that the voltage, which is of 2 volts, is enough to satisfy the needed conditions for this lamp. And this means that the rated voltage of this lamp is simply 2 volts. And moving to the fourth question, identify the open circuit. Which one represents an open circuit? Yes, it is the circuit in figure 2, because we have right here something made up of plastic, and we've said before that plastic is an example on insulators, and this means that the current is not going to flow because of this material. So we have an open circuit and the lamp doesn't glow. Now it's time to take something new. It's time to construct an electric circuit. So if you please, get a pen and a piece of paper and start drawing an electric circuit which consists of a dry cell, a lamp, connecting wire, and a switch. Yes, I know that. It takes time. So in order to make things easier, scientists give a symbol for each component. So let's discover these symbols. Starting with the dry cell, this is the symbol where we have this longer line for the positive terminal, and it is usually represented by letter P for positive, and the shorter one is for the negative terminal, and which is also represented by letter N. Moving to the motor, represented by this symbol consisting of letter M. We have the switch, and we have two cases. We have the open switch and the closed switch. Moving to the lamp, and then the connecting wire. Now you are ready to schematize an electric circuit. Let's start with the first one. Pause the video, and once you finish, check your answer. This is another example. Pause the video, draw the circuit using symbols, and then check your answer.
When lights are lined up one after the other on a circuit, like these lights are, it is called a series circuit. The problem with a series circuit is that when one light burns out and its filament breaks, it creates a gap in the circuit. All the lights go out because electricity won't be able to flow to the other bulbs. This problem can be solved with a parallel circuit. In a parallel circuit, the wires that are connected to light bulbs run parallel to each other rather than having all the bulbs in a row. This means that one light can burn out or be removed, and the other lights on the circuit will stay lighted. For example, if we remove the light that is closest to the battery, the other two lights don't go out because each light is connected in a way that the electrons have a complete path to travel to the positive side of the D-cell battery.
Now let's see what happens when we put another light bulb in series with this one. So here we have two light bulbs in series. Notice that the brightness decreased. The two light bulbs are not as bright as the individual light bulb before. So now we have three light bulbs in series with one another. As you can see, the brightness has been further reduced. So here's the first light bulb again, and you can see it's much brighter than the three light bulbs in series. Now what we're going to do now is we're going to connect another light bulb in parallel to this one, and we're going to see if the brightness is affected at all. Now we have the two light bulbs in parallel with one another, and as we could see, they are equally bright.
So let's summarize the characteristics of each grouping, starting with the series grouping. So here we have lamps connected in series. Keep in your mind that in series grouping, components are one after the other along the same path. And if we add another component, new component, this will make the function of the others weaker. And if one lamp is disconnected, one component is disconnected or broken, this circuit turns into an open circuit and the other components will lose their function. What about the parallel grouping? So here is a circuit with two lamps connected in parallel. So we see that the components are connected along different paths. Each component has its own path, and because of that, if we add more components in parallel, this will not affect the function of the others. And if one component is broken, this also will not affect the function of the others because of the same reason. Each component has its own pathway. let's go and make an application. We have two ways of grouping. We have series and parallel, and I'll show you two electric circuits. Pause the video and guess the type of each. Yes, this is a series grouping of lamps. Even they seem like parallel because of these parallel lines. However, they are present along the same single pathway, so it's in series. And the lamps right here are in parallel. Each lamp has its own pathway. Now it's time to schematize these two circuits using symbols. So pause the video and try it. Here is the first schematic diagram for series grouping, and this is the schematic diagram for parallel grouping. Now let's move to the second application. Here we have an electric circuit with one component, and we are going to add another component. If the addition decreases the brightness of the lamp, this happy face should turn into a sad face. If the addition doesn't affect the brightness, so the happy face should stay as a happy face. Pause the video and guess the correct representation and the incorrect one. And here is the answer. Moving to the last application, you have to check each of these figures and guess whether it's right or wrong. Pause the video and then check your answers. By this, we have finished the first part of DC voltage. And now you have to, and at the end I have to thank you for your attention.